How are you today?
I am fine, Miss. Thank you.
I'm fine, Miss.
I'm fine, Miss.
I am fine, Miss.
Before we start our lesson, first let's pray according to our belief. Prayer begins. Okay, finish. Okay, I will attend first. Ajeng. Ajeng. Fatima Nur Ikrom.
Present, Miss.
Gina Awalia.
Present, Miss.
Nur Kurniasi.
Present, Miss.
Rizka.
Present, Miss.
Salma Nadira.
Present, Miss.
Okay, my student. At this meeting, we will discuss material about mathematical induction.
Okay, Miss.
What is mathematical induction? Who can answer? Raise your hand.
I miss
Okay, Salma. What is?
mathematical introduction is a mathematical technique which is used to prove a statement, a formula, or a theorem is true for every natural number.
Okay, Salma, good. Anyone else can answer?
No, Miss.
If so, I will present the material about mathematical induction. Okay, mathematical induction. Introduction. In algebra or in other discipline of mathematics, there are certain results or statements that are formula in terms of n, where n is a positive integer. To prove such statement well, suit principle that is as based on the specific technique in is known as the of mathematical induction. Principle of mathematical induction. The principle of mathematical induction is one such tool which can be asked to prove a wide variety of mathematical statements. Each such statement is assumed as n associated with positive integer n, for which the, the correctness for the case n equals 1 is examined, then assuming the truth of p k for some positive integer k. The truth of p k plus 1 is established. There is given statement. Cn involving the natural number and such that 1. The statement is true for n equals 1. P1 is true and 2. If the statement is true for n equals k, where k is some positive integer, then the statement is also true for n equals k plus 1. EA, truth of pk implies the truth of pk plus 1. The third, then Pn is true for all natural number n. Induction. One key base for mathematical thinking is deductive reasoning. The second, deduction in a nutshell is given a statement to be proven, often called a conjecture or a theorem in mathematics. Valid deductive steps are derived and a proof may or may not be established. EA, deductive is the application of a general case to a particular case. The third,
Apa tuh yang jatuh?
deduction generalization specific instance. Okay, the fourth one such example is A. 8 is divisible by 2. B. Any number which is divisible by 2 is an even number. Therefore, and C. 8 is an even number. Induction. To understand the basic principle of mathematical induction, S suppose A set of thin rectangular tiles are placed in order as shown in figure. The second, when the first tile is pushed in the indicated direction, A, the first tile falls, and B, in the event that any tile falls, its success will necessarily false. And then this is underlying principle of mathematical induction. Type of question to be solved by asking PMA. The first statement giving expression about summation or multiplication of special series. Statement to show the divisibility of an expression by a certain natural number. The third statement containing 6 of inequality. Okay. Type 1 question. Q1 for all n greater than or equal to 1. Prove that 1 square plus 2 square plus 3 square plus 4 square plus n square equals n times n plus 1 times 2n plus 1 over 6. Hence, let the given statement be Pn. Pn equals 1, 1 square plus 2 square plus 3 square plus 4 square plus n square equals n times n plus 1 times 2n plus 1 over 6 for n equals 1. P1 equals 1 equals 1 times 1 plus 1 times 2 times 1 plus 1 over 6 equals 1 times 2 times 3 over 6 equals 1, which is true. Therefore, Pn is true, where n equals 1. Assume that Pk is true for some positive integer Kae 1 square plus 2 square plus 3 square plus 4 square plus k square equals k times k plus 1 times 2k plus 1 over 6. We shall now prove that p k plus 1 is also true. No, now we have 1 square plus 2 square plus 3 square plus 4 square plus k square plus k plus 1 square equals k times k plus 1 times 2k plus 1 over 6 plus k plus 1 square equals k times k plus 1 times 2k plus 1 plus 6 times k plus 1 square over 6 equals k plus 1 times 2k plus 7k plus 6 over 6 equals k plus 1 times k plus 1 plus 1 times 2 times k plus 1 times 1 over 6. Thus, p k plus 1 is true wherever pk is true. Hence, from the principle of mathematical induction, the statement is true for all natural number n. Key 2. Prove the following by asking the principle of mathematical induction for all n element n. 1, 2, 3 plus 2, 3, 4 plus n times n plus 1 times n plus 2 equals n times n plus 1 times n plus 2 times n plus 3 over 4. Hence, let the given statement be Pn. Pn equals 1, 2, 3 plus 2, 3, 4 plus n times n plus 1 times n plus 2 equals n times n plus 1 times n plus 2 times n plus 3 over 4 for n equals 1. P1 equals 1, 2, 3 equals 1 times 1 plus 1 times 1 plus 2 times 1 plus 3 over 4. 6 equals 1 times 2 times 3 times 4 over 4. 6 equals 24 over 4 equals 6. which is true. Therefore, Pn is true where n equals 1. Assume that Pk is true for some positive integer k. Equals 1, 2, 3 plus 2, 3, 4 plus k times k plus 1 times k plus 2 equals k times k plus 1 times k plus 2 times k plus 3 over 4. We saw no proof that p times k plus 1 is also true. Now we have equals 1, 2, 3 plus 2, 3, 4 plus k times k plus 1 times k plus 1 plus 1 times k plus 1 plus 2 equals k times k plus 1 times k plus 2 times k plus 3 over 4 plus k plus 1 times k plus 2 times k plus 3 equals k times k plus 1 times k plus 2 times k plus 3 plus 4 times k plus 1 times k plus 2 times k plus 3 over 4 equals k plus 1 times k plus 2 times k plus 3 times k plus 4 over 4. Thus p k plus 1 is true whenever pk is true. Hence, from the principle of mathematical induction, the statement Pn is true for all natural number n. Okay, my student, from the material that I have described, do you have any question?
No, Miss.
Do you understand?
Yes, Miss.
Yes, Miss.
Yes.
Good, if you understand. For further understanding, you can see in classroom.
Okay, Miss.
Okay, for our meeting today, it's finished. To end our study, let's pray. Pray begins. Finish. Okay, my student, good morning. See you at the next meeting.
Okay, Miss. Good morning. Thank you.
Morning, Miss.
Thank you.
Thank you.